Hello, and thank you for joining us today. Control Station is pleased to host you for our web seminar, 3 Truths of Data Analytics. My name is Dennis Nash. I'm the president of Control Station. I'm joined today by Dr. Bob Rice. Bob serves as Control Station's Vice President of Engineering. As the company's Chief Product Architect, he oversees product development and engineering services. Bob received his undergraduate degree in chemical engineering from Virginia Tech, and his master's and doctoral degrees were received from the University of Connecticut. Bob has published extensively on topics associated with automatic process control, including multivariable process control and model predictive control. Today's presentation will be delivered in 3 parts. We'll begin with an overview of Control Station and provide details that characterize the company's credentials within the rapidly growing market for data analytics. The core of our presentation today will examine 3 truths, or common aspects of data analytics initiatives that contribute to either their success or their failure. We'll conclude with a question and answer period. Please feel free to submit your questions using the chat function located at the top of your screen. And with that, I'm pleased to introduce Dr. Bob Rice.
Excellent, Dennis. Thanks for that introduction. And thank you everyone for joining us today. What I'd like to do is to start with a little bit of background behind Control Station. Control Station is a leading provider of data analytics software. We've been in business for over 33 years, and over those 33 years, we have been innovating within data analytics and loop analytics. We have installations in over 70 countries supporting 50% of the Fortune 500 manufacturers. We have a wide range of expertise in oil and gas. Starting with the training portfolio within Control Station, we've developed an APC curriculum for a large oil and gas provider. We've also delivered training solutions to a number of other oil and gas type of customers. We've also developed a world-class PID tuning software, which we've private labeled with a number of different DCS manufacturers. We also engaged a number of leading oil and gas producers from North America a little over a decade ago for our original pilot program when we developed our plant-wide monitoring platform, Plant ESP. We engaged these customers to understand what is it they were looking for? What are the tools that are needed to be able to accurately monitor your controller assets out in the field? We also provide staff augmentation services where our team of process experts can remotely analyze or on-site augment your staff to be able to make sure that your data analytics, your control optimization investments and opportunities have the right staffing attached to them. Plant ESP is our process analytics and optimization platform. It is a tool that's hosted with a HTML5 web portal, and it can go out and it can monitor thousands of controllers. So it can scale from very small installations of maybe 10 or 15 or 20 PID controllers to well over 1,000 controllers that may span across your entire enterprise from multiple sites. As we start to get into this, the 3 truths discussion, I'm going to talk a little bit about the architecture and design and how these types of flexible architectures can be used to handle multi-site type applications. The big thing with Plant ESP is it really facilitates the ability to sustain those performance gains. So when you go out and you do your optimization exercises, that you have the tools and solutions in place to make sure that those gains are held over the long term. From a basic architecture standpoint, Plant ESP is a tool that sits on top of a data historian or sits on top of multiple data historians. And so you can have a central tool that can connect to multiple different silos of data, consolidating it and providing a number of different calculations and analysis tools within a single platform. It has the ability to calculate advanced KPIs. It has the ability to do benchmarking automatically across all of your data, whether that's hundreds or thousands of loops, saving you a lot of time in commissioning and long-term use. It also provides a number of different tools for being able to do forensic analysis and root cause analysis, to be able to actually identify not just that you have an issue with one particular area of your facility, but how does that issue propagate throughout your plant, and how can you trace it to its point of origination? There's also a number of alerting and trending and dashboard and reporting tools within the software as well. And so there's a web UI that you can interface with. There's emailed reports. But what's unique and interesting is the entire back-end calculation result database is exposed through a SQL schema, REST APIs, and so forth, that now you can consume this data with other tools. So whether that's Power BI or Element Analytics or Seek or Data Miner or whatever the other tools that you're using to consolidate multiple types of analysis, you can bring this data up and now use it in more advanced, higher level type of analysis. The other thing that makes the flexible design of Plant ESP unique is that you can do single site deployments. So these are a number of our oil and gas single site deployments across the globe, where there's a single installation at a single plant that's monitoring the assets at that one location. But you could also design a multi-site deployment. So we have a number of oil and gas customers that are having a single installation of Plant ESP, but they're actually monitoring multiple plants within a particular division or fleet within their enterprise. And so you can have, again, a central ESP server monitoring, a division. You could even take what another one of our oil and gas customers are doing and being able to monitor all of their facilities from a central location where they can go and have one installation of our data analytics tool monitoring dozens of facilities across the globe to bring the information into a single silo of data that now allows you to do cross-site comparison in analytics and analysis. So that takes us to the three truths, right? We've been deploying Plant ESP for a little over a decade now to over 150 plants. And at this point, we're monitoring just a little over 40,000 PID controllers. And I can tell you, we've learned a lot, right? We have a lot of bruises, and we've learned a lot over this time. And I want to try to share some of that information, right? I want to try to share some of the ideas behind time, right? What are the three truths, right? The truth is time, data, and knowledge, right? How do you understand the impact of time on the success of a project? What about the types of data and how that data is stored and organized? And what kind of knowledge do you need to be able to succeed in these types of applications? First one is time. And this one's kind of interesting. Optimization is not a destination, it's a journey. It's not a singular event that occurs. It's something that you start and you continue, right? You're going to continue to do optimization. You're going to continue to do this as a function of time. It's not going to go in and you're going to do your event and everything's going to work and that's going to sustain. You've got to make sure that you're out there, you're monitoring, and you're doing your analytics, and you've designed your project to last over time. Because the truth is, most manufacturers underestimate the amount of time and resources needed to really do a true data analytics initiative, right? For it to be truly successful, you have to make sure there's organizational commitment, not at the individual plant level, but also at the corporate level and at the intermediate level. You got to make sure that all levels of your business buy into the idea of analytics, to make sure there's ownership and that there's an understanding that this isn't a singular event that has to occur. It's something that continuously is moving on with time. So you have to have a continuous improvement, culture at your facility where you actually want to make sure that you're continually doing these types of initiatives, that you're documenting and learning your lessons, you're documenting your best practices, you're creating your standard operating procedures, you've made sure you've outlined your goals and resources, and that all of these things take time, right? It's not something that you're just going to implement and you're done with it, right? It's going to be something that you're going to have to continually improve upon and go back to and sustain. And so what I want to do is go through kind of a quick example of where time in sustaining was an interesting lesson learned. So we had a customer that would go out and they would do a control strategy Kaizen, which is basically they analyze the operations, and they would go and they would implement all of their control strategies, their control narratives. They would implement it and they would see big gains, and then they would leave and the performance would drift off. Then they would go back again, ask them, why is everything turned off? Let's get it all back running again. And they would implement it, and then they would leave and it would all disappear again. And what they found is that the local team really lacked the training and the tools to monitor and sustain those gains. And they found that 30 to 40% of those gains were gone within 3 to 4 months after implementing it. So they constantly had to go back and redo the whole project over again. Implementing a tool like Plant ESP to make sure you get the analytics to monitor and track and make sure those improvements are sustained, they found that they could go revisit the site, get the system optimized, deploy Plant ESP, and hold it there. So you can see that there was a dip, but then they were able to go back very quickly to site personnel because now they had the tools to be able to identify, well, here are the assets that are drifting. Let's focus on those and be able to get their controller utilization in this point to closer to that 100% mark. This is data from 2017. If you look at it from 2017 to current, it just sits right at 96, 97, 98%. And they've been able to duplicate this across all of their facilities. So they've put in a process because they understood it was a journey to go out and do the controller optimization, build the narratives, build the strategies, the standard operating procedures for how their loops are supposed to be operating, deploy their sustaining tool within Plant ESP, and sustain those benefits over multiple years versus just the first 3 months. So understanding it's a journey, not just a destination. But to do data analytics, you gotta have data, right? It's part of the phrase. More isn't always better, right? Sometimes it's just more. Data is prolific. It's everywhere now. We're collecting all types of data, right? But is it the right data? Is it stored in the right format? Is it accessible, right? Is the resolution pretty good? All of those questions have to be answered because I don't know how many sites I've gone into to go and deploy an analytics solution to realize they thought they had a ton of data when in fact they really didn't. They were missing the appropriate information. They may have just been collecting high-level temperatures and flows and pressures. They weren't collecting all the information to be able to give you a complete picture of the behavior or the performance that they're looking at. And it's not just your traditional process controller data. Even for controller analytics, it's not just the process variable, the set point, the output, the mode. There's data that gives context to that controller's operation. Is the loop in service? Is it running under certain conditions, right? Being able to add additional information to be able to add context to the results is really important. What do I mean by context? I mean being able to add additional information to the data. So if you're talking about a particular control loop, maybe you can store, if you're using different cuts of fuel to run this unit operation, you can store that information, right? What about the operations team that's in there? What about the outside temperature? All of that can have influence into the analytics. Being able to track and do that information gives you the ability to create state-based metrics, not just looking at the individual data and this controller is not behaving well, but it's, hey, this controller doesn't behave well when these conditions are present, right? So it really allows you to help you understand and conceptualize what's going on. Additionally, you want to make sure that your data is easy to get to and is centralized. If you think about the traditional model for data historians, for reporting and analysis, everything lives at the plant, right? You've got your plant DCS, your PLC system, your control platform. You've got data being collected. You've got reporting and analytics all being done at the plant. And you have your experts and analysis being done at the plant. Okay, so when you only have data at the plant, you have all these walls between all this other expertise and other information that you can start to kind of bring together to understand, is this plant actually behaving really well, or is it behaving better or worse than the other plants that are similar to it, right? Now you can start to identify outliers if you can break the walls between all of the data, right? So those structural aspects of having all of your sites individual is going to really limit the ability of your analysis, right? There's also a lot of redundancy, right? Especially when you think about the data analysis and the expertise that lives at each one of these sites, right? To be able to actually share information, to share knowledge, you got to break down those walls. You got to be able to allow data to be flowing from site to site, central locations, be able to have the people at each of the sites see data at other locations to see, is what they're seeing, is it unique to them, or is it something that somebody else has seen and already has a solution to? So to be able to centralize your analysis, move your data to a central historian. And a lot of the data historians out there now provide this type of capability where you can have an individual data historian at the site because you may store more data there, right? But then pipe data over to a central system and then build your analytics on top of that central system so you don't have redundancy in all of your tools. It allows a much more efficient way of deploying tools, much more cost effective and time effective and resource effective, right? You don't have to have lots of experts at each of the sites because unfortunately we don't have those experts at each of the sites, right? You're starting to move those experts to those central areas of experts, right? You're going to have a group or a room at your corporate location. It's going to have your data scientists, your data experts there, and now they can share that information across multiple sites. You can share those resources, and again, you can build much more powerful analytical engines because you've got this central system that stores all the data from all the different sites. Knowledge. This is an interesting one, and the quote is interesting, right? If you want to succeed, limit yourself. That seems counterintuitive. You want to succeed, you don't want limits, right? But the truth is, the unicorn expert that knows everything, they're becoming very, very rare, right? They're like unicorns. They may not even exist anymore, right? You got to have experts in process engineering, in controls engineering, in cybersecurity, in data analytics. You got to have the data scientist. You got to have the person who can take all that information and describe it as business KPIs, right? A singular person that can have all of that knowledge is very difficult to do. So it's really designed about diversifying your team, be able to bring in the experts, the data scientists, the experts in extraction, in processing, in controls, in cybersecurity, in data collection, in IT, and understanding what are the business KPIs and the business needs. All of those are different skills. So having a diverse team is really going to help you save time in doing these types of analysis, right? Time sharing is really important. A singular person may have the skills to do all of this, right? But they're not going to do all of those as effectively as other skills. They may be really good at controls engineering, developing control strategies, and they may know a little bit about data analytics and data science, right? So they're going to go and do their data analytics, data science, and it may take them 20 or 40 hours to go and do that analysis, whereas a data scientist could do it in 1 or 2, right? Can you figure out how does that Venn diagram of diversity within your team become effective, right? How do you share the time? Do you have the right technology to solve your problem, right? Or are you using Microsoft Excel for all of your data analysis, right? I love Microsoft Excel, but it's not the right tool for every type of analysis, right? Using things like Power BI or Plant ESP or specific tools to do a specific job is far more efficient. If you think about all of the priorities that you have at your facility, right? This particular example, there are 3 control engineers responsible for 3 complexes and over 3,000 loops. This would cost 20 or 30 square miles, right? They had the expertise, they didn't have the time. And so there were a number of reports and opportunities that they were identifying, and little or no progress was being made to complete these assigned tasks because they didn't have the time. They were too busy making sure the plant was running, making sure the new instruments were coming online, the new units were coming online. Well, optimization was part of their job requirement. They just didn't have the time. So how can you leverage teams of experts to be able to do this more effectively, right? So Control Station has a room of experts on process controller analytics and data analytics. We can provide remote support to be able to help that customer do the analysis and give them a much more shorter, actionable list of opportunities to say, here are the 3 things you need to focus on out of the 1,000 opportunities, and these are the things you need to do to those to make them better, right? Take our experts who have years of experience doing this specific type of analysis, and in short work, we can give you the work items, the opportunities, without you having to do all of that effort, right? It saves time. It allows the control engineers to be more effective with the very little time that they have to do everything else at their site, right? To be able to leverage that team of experts. That's really important to make sure these projects are successful. So what are these 3 truths, right? Time, data, and knowledge, right? With any data analytics type of project, you need to make sure that you are prepared for and commit to the journey. It's not a 6-month, a 3-month, expedition, and you're there, you find your gold, and you leave, right? You want to make sure that it keeps producing, that the opportunities are sustained, and so you have to commit to that journey to make sure that it stays there for the long haul. You also want to make sure that you have access to and centralization of good data, right? You want to make sure that the access to the data is easy, that multiple tools, multiple people can be able to access a single source without having to go all over the place to be able to find the solution, right? If you make it easy, more information will come out of it, right? More tools are going to be available to you, right? Centralizing the data makes it a lot easier to deploy. Making sure you leverage internal and external team of experts. Make sure you leverage the experts when you need to. You may have a ton of process and institutional knowledge within your facility, but to be able to leverage an external team can bring new light to the situation, right? Can bring new experience. And especially if they're focused experts in particular areas, you'd be surprised what new information can be brought that you may not have seen before. So I appreciate everybody's time. And now I'd like to go through a few Q&A here. I know we've got a few chat messages in here into the Q&A queue, and I'm going to have Dennis read out the questions here, and I'll go through the answers.
Great. Thank you, Bob, for sharing those insights. While the content you shared was oriented towards the oil and gas sector, it's clear that process manufacturers of all stripes would benefit from these same opportunities, and they'd be susceptible to the same challenges. Like Bob noted, we'd now like to spend the remaining time addressing questions submitted by today's event participants. A few questions were submitted during the presentation, and we'll begin with those. Again, for those still interested in submitting a question, please use the chat function so that Dr. Rice and I can provide a response. The first question that was submitted, Bob, what results have you seen from the use of PID loop analytics?
That's a good question. The results are positive, right? When you go out and you do controller performance monitoring, you stick to the package, you stick to the program, and you do that continuous improvement. We've seen customers improve throughput by 3 to 5% on certain applications. We've seen customers decrease energy usage. We've had one particular project where we went through and did optimization and focused on energy usage of heavy utility type systems within an oil and gas customer, and we found close to a low six-figure improvement by just doing optimization on really close to about a dozen loops. So the dollars are there, optimization efforts are there, and you can get to real dollars, whether it's looking at energy improvements, increases to throughput, or looking at quality to make sure that you're getting the right cut of products through your different units.
Okay, great. Another question that was submitted, and I'm going to paraphrase this one. You spoke about the need for high resolution data, but what details can you share about data requirements?
That's a good question. Good data depends, right? What is it you're trying to see in the data, right? I would like to say that you need to make sure you're collecting all the right tags, right? You want to make sure for at least a controller analytics type solution, you're looking at things like controller output, process variables, set point, modes, and as I mentioned earlier, things that provide context to the data. Is the loop in service? Is it running a particular recipe or cut? Is it is there a shift log that maybe operators may run the units or the loop a little bit differently to be able to provide context? Make sure all that data is being collected. Then it comes down to how quickly does it need to be collected? Faster is better, right? We want to make sure that we're in the 1 to 2 second range for most controllers, right? You never ask what you don't, you never get what you don't ask for, right? I'm going to ask for 1 second data. Am I going to get it? No. But we want to make sure you're collecting data fast enough to see what you're interested in. If you want to see an oscillation or behavior that occurs in the 2 to 3 second kind of time window, and you're collecting data every 30 seconds, odds are you're not going to see it, right? So if you're really going after that kind of high frequency type events, you're going to need high frequency data. If you're going after slower loops, slower systems that take, hours or many minutes to respond, then the 30 to 60 second data is acceptable, right? So you really need to make sure that you design your data resolution, your exception, your compression settings, your scan times, your scan classes, all that stuff to make sure they're fast enough to see what it is you're interested in.
That's a great reply, Bob. Next up, you spoke about long-term success. So how can you assure long-term success through the use of data analytics?
That's a tricky one, right? The big one is it's commitment and accountability, right? Are you committed to using the tool, to putting it as part of a process, right? We've seen our best success in long-term data analytic projects when it's part of a process. It's not just, I'm going to load up the tool whenever I have a problem. It's, hey, I'm going to actually be part of a weekly or a monthly report that's going to give me these are the opportunities. And now I am held accountable to make sure I can explain why these things are in red, to get them out of the red, to make sure that you continue to drive those improvements, right? So key to successes are accountability, ownership, and make sure you keep using it, right? Make sure it's part of a process. That will ensure success.
Okay, looking at the clock, and we're going to make this the last question for today. A question about the cloud, Bob. What role does the cloud play in analytics solutions like Plan ESP?
That's a great question, and the cloud is the great consolidator, right? It's being able to take all of the data from different sources and put it in a central location, and it allows easier, more diverse access to the data, right? So being able to put stuff up in the cloud allows remote experts to be able to access it, allows you to take different tools to bolt onto that data that living in the cloud, provide more information. And so it allows you to centrally access that type of data. So being able to put it in the cloud really opens up the doors to having more data, more ease of access to that data, more central access. So you're not pulling it from multiple places. So it really provides a lot of easy ways to get access. There are obviously a lot of cyber concerns, security concerns associated with it as well, but there are a lot of solutions out there that have satisfied those requirements. And being able to put the data in a central location really allows those experts in a room to do the analysis appropriately.
Well done, Dr. Rice. So thank you for joining us today. We will post a recording of our presentation on our corporate website at www.controlstation.com. Additionally, we will be happy to share written responses to each of the questions that were submitted today by event participants. Again, thank you for joining us. Enjoy the rest of your day.